Hello everybody and welcome to a new video on this channel. Today I will show you and talk about how to ZScore data in GNU Octave. So what is a ZScore? We talk about statistical data. So imagine you have a vector containing sample values from a certain distribution, from a normal distribution. And a normal distribution is defined by two values, a mean value and a value for the standard deviation. And the ZScore transforms each normal distribution to a standard normal distribution. So a standard normal distribution is also a normal distribution, as the name is indicating, but a normal distribution with the mean value of 0 and the standard deviation of 1. And this is what the ZScore is providing you. It's a very easy tool to transform any normal distribution to a standard normal distribution. Why? So first, in one application of this approach is to use it as a tool for denoising data, because you average the noise, or you normalize the noise values to have a mean of 0 and the standard deviation of 1. So denoising is one option where you can use the ZScore tool. And the other one is, for example, you have, let's say, two different vectors containing samples of two different normal distributions. Let's say one vector contains samples from a normal distribution with the mean value of 10 and the standard deviation of 3, and the other vector is containing values from a normal distribution with the mean value of 6 and the standard deviation of 2, for example. And now you want to compare both data sets, and then it's easier to normalize both data sets to a common ground truth, in this case to a standard normal distribution with mean 0 and standard deviation 1. And so you can compare both. For example, calculate the probability of occurrence of a certain value and so on, which by the way will be part of our next video, or one of our next videos, where we'll show how to calculate the probability of a certain value occurring in a normal distribution. And yeah, that's what the ZScore is providing you. A normalization tool that you are able to compare data from different normal distributions by transforming the samples from these different normal distributions to a standardized normal distribution. So let's directly head over to our workspace and demonstrate it with a very small and basic example, because the ZScore calculation is super easy but very powerful. So we start our script as usual with clear all, clearing all workspace variables, close all, closing all maybe opened windows, and CLC, clearing our command line. So whenever it comes to statistics, it's useful to load the statistic package provided by GNU Octave by typing package load statistics. For sure you have to install the statistics package before you can perform this operation without any error. And I will give you the link where you can download the statistics package in the description below the video. So let's generate some test data. So a vector containing samples from a normal distribution with a certain mean and standard deviation value, and then let's ZScore them to a standardized normal distribution with mean 0 and standard deviation of 1. So let's choose an arbitrary mean value of our for our normal distribution. Let's say a mean value of 4, and the value for the standard deviation, let's call it sigma, which is common in literature, of let's say 3. And we want to generate a certain amount of numbers from our normal distribution. Let's call it n for n samples. And let's say we want to generate 1000 samples of our normal distribution with mean value 4 and standard deviation of 3. So to generate the normal distributed values, we can take the norm R&D function provided by the statistics package, and we have to pass 2 arguments to the norm R&D function, which is for sure the mean value, and a second argument, the standard deviation, sigma, in this case 3, and yeah, for sure we have to pass also the amount of numbers that we want to generate. We want to generate a row vector, so 1 row, and the number of columns is equivalent to our number of samples that we want to generate, and samples. So now we've generated a sample vector X containing normal distributed values with the mean value of 4 and the standard deviation of 3, and we've generated 1000 samples of this distribution as a row vector. So let's have a look at the distribution of this data set by using the histogram command, and it's quite easy. Just type hist and pass the vector to it that we have from the data that you want to display, or where you want to display the probability density function. So let's fire it up and have a look. So I will show it to you. Oh, give me a second to switch the window. So here it is. This is our histogram of our generated sample vector X. Samples from a normal distribution with mean value 4 and standard deviation of 3. So yeah, it looks normal distributed. For sure you can increase the bin count of the histogram, so the bins are the different bars here, to make it more smoother, but it's okay for what we want to show here. So let's go back to our workspace. So now we know we've generated a vector that is normal distributed, and now we want to ZScore this vector. Let's call it X ZScore, which will be our standardized vector, standardized to the normal, to the standardized normal distribution with mean value of 0 and standard deviation of 1. So it's quite easy. What you have to do is take your sample vector and subtract the mean value of the whole sample vector from each single element in the vector. This is done by this formula here, x minus the mean value of x, and then divide each single value of x. Each single means point division. Divide each single value, a remaining value, by the standard deviation of x. So this is the ZScore calculation. So quite simple, subtraction and division, so pretty easy here. And now let's also plot the histogram of our standardized normal distribution. And therefore we make a subplot for better comparison. A subplot with 2 rows, 1 column. In the first window we will plot our histogram of our original data, our non-standardized data. And in the second subplot, the histogram of our standardized data. And the shape stays untouched, so the shape of the distribution will be the same. We only scaled the distribution and shifted it to a mean value of 0. So and hist of X ZScore, which is our ZScore data. Let's fire it up and let's have a look. So we'll directly head over to the result, and here it is. So in the upper plot you can see our original data, sample value, mean value of 4. You can imagine that this bar here is at 4, and the standard deviation of 3. And then we've applied the ZScore transform to our data set, transforming our normal distributed values from the top to a standardized normal distribution at the bottom. and you can see now here we have a mean value of 0 and a standard deviation of 1. So, but let's also verify these values by calculating them, the standard deviation and the mean value. So let's calculate the mean value of our ZScore data, x ZScore, it's just the mean command, mean x ZScore, and it's minus 1.49 minus 15, so it's 0. And let's calculate the standard deviation of x ZScore, which should be 1, and it's 1. So perfect, we've transformed it to a standardized normal distribution. But there's also a function that is provided by the statistics package, which is called ZScore, and this function is doing exactly what we have programmed here manually. And x ZScore GNU for GNU Octave, and the function is called ZScore, and you only have to pass your vector that you want to ZScore through this function. So let's also plot the result provided by the GNU radio function, GNU Octave function, and let's also plot it to our figure. So let's create a subplot with 3 rows, and let's also plot the histogram of x ZScore GNU for GNU Octave, GNU radio. I was thinking all the time about GNU radio. And let's make a title, ZScore function GNU Octave. Then in the middle we have the histogram of our transformed data, ZScore manual, and the first plot contains our original data. Data samples from a normal distribution. ZScore manual. So let's fire it up. Oh, we have made an error. Oh, sorry. It's a 1 because we have 3 rows in our plot and only 1 column. And so let's head over. And here it is. Again, the first plot shows our original data. The plot in the middle, or the histogram in the middle, shows the probability density function of our ZScore data, ZScored using our manual approach. And the last plot with an indice error here in the title shows the ZScore data using the provided function from GNU Octave ZScore. And it's exactly the same result. So let's go back to our workspace and let's fix this bug here. And let's also have a look at the ZScore data, if it's really the same between our manual approach and the GNU Octave version. Let's have a look at the first 10 samples of each result. X ZScore and X ZScore GNU 1 up to 10. And as you can see, the vectors are the same. And yes, that's the ZScore. Very powerful tool, again, for denoising data, especially in signal processing, and very important for the comparison between different data samples from different normal distributions, to transform each sample to a standardized normal distribution. So, thank you very much for watching this video. See you the next time. Bye bye.